project assignment reaction engineering. Let's go. So this is our reactor. It's called plug flow reactor, PFR. So this is a PFR, plug flow reactor. So it consists of inlet and outlet. Then inside here, it consists of tubular tube. So that's all.
We connected to the main controller where we can start the pump and thermostat as well as to control the flow rate of the system.
Plug flow reactor (PFR), or sometimes known as continuous plug reactor or piston flow reactor, is a continuous system of cylindrical geometry. It is flowing as a series of indefinitely coherent plugs.
It is an assumption that the fluid is perfectly mixed in radial direction but not in axial direction. Cumin is a chemical process reaction from benzene react with propylene. So there are two common processes that can produce cumin, which is first process, there is no PFR, so there's less distillation column in it. Second process, there's a lot of distillation column and have the reactor PFR. So for the first process, the advantage is it has less distillation column, so it is very cheap. For the disadvantage of the first process, it produces low purity of the product. So for the second process, the advantage is it can produce high purity of product because of the high distillation column, but the disadvantage is it is very expensive. So for the improvement, for the first process, we can increase the number of the distillation column. For the second process, we can improve by combining reaction process and distillation process into reactive distillation. Thank you.
On stage 1 for student 2, the process background was done on both reactants and product of the reaction. And for this case is for cumin production. For cumin production, the reactants are propylene, benzene to produce cumin, while the side reaction is propylene react with cumin to produce diisopropyl benzene. The physical properties of the reactants and product are all in gas phase and colorless, while the odor is odorless for propylene and propane, petroleum light for benzene, and pungent for cumin. And lastly, for the solubility, all substances, reactants and product are not soluble in water, or some is slightly soluble in water, and most of them is soluble in alcohol or organic solvent.
Process background for cumin production. Cumin is a gas-phase reaction process where it is initially introduced by Heinrich Hoppe, where Friedrich-Kraft alkylation is used. There are several conditions and parameters that are required in order to achieve maximum yield. The condition that are required for the reactor in this reaction is 377.2 degrees Celsius. The requirement is needed to maintain the phase of material and improve selectivity of product. Next, the inlet pressure required by the reactor is 40 bar to increase the rate of reaction. Lastly, the conversion of the PFR is 99%, as the propylene is a limiting reactant and act as a basis of calculation. Thank you.
So I will explain about the background of the PFR. So the PFR model is used to predict the behavior of chemical reactors. This invention is proposed by Dankert in 1953 to present a pulse of detector into the fluid entering the reactor, and then interprets the reading when it leaves it. So by that, it can easily measure the reaction within the reactor. Then later chemical engineering starts to provide antibiotic for process of without having any transfer of mass and heat on its surrounding. Then for the application of PFR, it can be used for Grignard reaction, oxidation, hydrogenation and saponification. Oh, not to mention, it also can do for polymerization, synthesis and extraction. Thank you.
So for the production rate assigned for this group is 3.5 million pound per year of cumin. But in our journal is 100,000 metric ton per year. So for our mass balance, we are using a method called as scaling down method. So when we use the scaling down method, we can obtain the required values for our calculation for the mass balance. So for the production rate increment, as the production rate increment increases, the mass flow rate of the each species also increases linearly. Thank you.
On stage 2, for student 2, stoichiometric table was developed for the reaction, and in this mini project, stoichiometric table is developed for cumin production. Stoichiometric table is to express concentration as a function of conversion. Stoichiometric table is to express concentration as a function of conversion, and to combine the conversion function with appropriate rate law to obtain the rate of reaction. This is below is the stoichiometric table for cumin production, and also the conversion function derived from the stoichiometric table. In this main project, the increment effect of when one of the raw material increase is studied, and here is the analysis of the effect.
For stage 2, I will explain about the reaction kinetic. The rate law of the reaction is an irreversible elementary rate law, negative RA equals to KCACB. Next, I will explain about the effect of parameters to the reaction. We can refer to Le Chatelier's principle, where the factors affecting the rate of reaction are temperature, pressure and concentration. Firstly, as the temperature increase, the rate of reaction also increase. Then, pressure will affect the value for concentration and rate of reaction. So, as the pressure increase, the concentration will increase as well as the rate of reaction. Both temperature and pressure are directly proportional to the rate of reaction. However, the conversion is inversely proportional to the rate of reaction. When conversion increase, the rate of reaction also decrease. Thank you.
So from the calculation of volume, we can relate the constant rate reaction, which is negative RA equals KCA squared. So from that, we can find out the three effects affecting it. So for temperature, when temperature increase, volume increase. For when it decrease, volume also decrease. And for pressure, when pressure increase, volume also increase. And for pressure decrease, volume also decrease. For conversion, when conversion increase, volume also increase. And for conversion decrease, volume also decrease.
you.